Welcome everyone. I'm Yuncheng. I'm a software engineer in Huawei, and I have been working in the operation and maintenance area for about 3 years. And I also actively involved in the openEuler's community as a commuter in ServerSig. And I'm glad to be here and share with you all our latest progress about the project called AOps. Yeah, here I'm gonna introduce it from the 4 aspects. So firstly, what is AOps? So broadly speaking, AOps is an end-to-end solution for user to for detection and diagnosis, then repair. So here we divide the whole process of the maintenance work to 3 layers. The bottom layer, we call it data collection layer. Here we have an agent to collect the data from user's host. We have an agent to control many different collection tools to collect. And the data includes the metric data as well as the log data. And one of the most important tool is called Golfer. So it uses eBPF to collect very deep level data from both and user mode. And the middle layer, we call it initial diagnosis layer. So in this layer, we can still use some tools to conduct some initial diagnosis so that we don't have to push the heavy data to the outside. For instance, if you want to try to diagnose the OOM right out of memory, you don't have to transform the VM core to outside, which is very heavy. And the top layer, we build a set of microservices and support many features so user can for instance, do the routine inspections and AI diagnose and CV hotfix and other many interesting features. And for user to scan and repair the entire cluster, not only one. So here I'm gonna introduce the AOPS 3 main features. Firstly, is the full stack observability. It is provided by Golfer, which is a daemon that provides lot of eBPF-based probes combined with the uprobe and tracepoint and kprobe to collect the data from the kernel and driver and syscall. So it's very convenient to our user to develop their own plugin. Yeah. So right now we have covered the kernel runtime and some other user mode software like Redis and Nginx. So as you can see, when we got the data from the probes, it can be restored. It can be stored as a matrix in the database. For instance, Prometheus, right? Or it can be transferred via Kafka to for other use. And with the data we have, we can do many interesting things. Like we can draw a real-time topology based on the TCP or IP communication data. And with the topology, we can do the cluster fault localizations with data like the response time or latency of the request. You can easily localize the fault, and you can see which part of the cluster is wrong. And finally, you can also do the fault diagnosis. We have covered like I/O and memory and even performance. You can do the online performance profiling. Yeah, which is pretty cool. Here is some charts made by the Golfer. You can see it covers most of the useful data we can use in daily maintenance work, like the applications API performance and the TCP IP data, and also they can draw the flame graph of the CPU or memory. And they can also do the online profiling based on the on-CPU or off-CPU analysis. And another function of AOPS is vulnerability management. As we all know, the security of OS is very important, right? And openEuler publishes the update version every week. So, for instance, if you have a CVE in your kernel, you can just download the upgraded one to upgrade the kernel and then reboot the system, and the CVE will be fixed. But in most cases, this will be work. But in some emergency cases, so user cannot just reboot the system and active the new kernel, right? So we can use the hot patches. And here we build a brand new hot patch production pipeline, and to produce the pipeline in with the code patch PR, which I will describe later in the demo. And with the published hot patch, we can scan the hosts in the AOps website, and we can also generate a fixed task to define the host you want to fix and the CV you want to fix, and even the fixed way, like you want to use code patch or hot patch to fix the CVE. Then after the the CVE is fixed by code patch or hot patch, we will scan it again, and we will update the state in our database. So since we can scan and repair it in batches, the efficiency is very increased significantly. And how do we manage the hot patch in the system? So we try to be consistent to users' habits. In openEuler, we use DNF to manage the packages. So here we just develop another DNF plugin to manage the hot patch life cycles. And you can see here we support different commands of the DNF to scan the CVE and also install and upgrade the hot patches. And in a lower level, we actually call the cscar using the command line. And cscar is another open source project in openEuler. It unifies the kpatch and upatch external interfaces, so it is easy to manage both of them at the same time. And it also provides a complete lifecycle management from the not applied to deactivated, then active. And the traditional hot patch will be deactivated after you reboot the system. So the CV will be exposed again, which is not what we want. So here we add a new state called accepted. So if you accept the hot patch, means after you reboot, the hot patch will be active again automatically, which is pretty cool. And so the final feature I want to introduce is the configuration tracking. According to the statistics of our maintenance and SRE team, we found that over 80% of OS failure caused by the changement of configurations. Like if you change the /tab, it easily can cause the boot failure, right? And here we set the baseline of the host, and we will regularly scan all the hosts and report the detected modifications. And we will also do the version control of the configurations. Yeah. And so finally, we have a future plan of combining the GPT with our AOps. So we try to, we have chosen the GPT called LogGPT to help us to predict the next line of the log, so that we can compare the prediction log with the actual log to see if there is anything goes wrong. So we can just give the model the log file, like the messages file, and the code file and the case file of the maintenance work. It will do a great job and help us to tell the log if have anything wrong, not just give them a specific rule, right? Okay. So here I prepared 2 demos for hotfix. The first one is how we made a hot patch in the community. So firstly, we just find the PR in the kernel repository. And here, I just randomly pick one. And here we just need to comment here, make a comment here. Here I omit some parameters. And it will automatically trigger a new PR in the hot patch meta repository. And in this PR, it will record some basic info about the hot patches, like which source RPM I'm going to use, and which debug info RPM, and the specific content of the patch. So the PR will start running with the CI system, and after the build is done, we will test it in community. And you can also see the anniversary we have published here. So here are the anniversaries we have published, and you can see the detail of about the CVE, and also you can download the hot patch online. Yeah. So with the metadata on the PR, you can actually rebuild the hot patch by yourself. Okay, the next the next demo is a demo show how we fix it by AOps. So firstly, we log in and we have a dashboard here to show some basic info about the cluster. And here we can see all the hosts we have in the cluster and their like online status. And we can also add the host in batches with Excel. Here we can also separate them in groups. And in the CV page, we can see all the hosts we have, all the CVs we have in the cluster, and how to fix them, the specific RPM and their version. Then we can, we can also see how many CV we have fixed, and we can also see the CV from the host perspective. So here we just enter one host and we can scan it, and we can also export the CV information about the host. It will generate an Excel which shows the detail about the host CV info. Yeah, so here I just choose a CV which can be fixed by hot patch. And here we choose hot patch to fix the CV and generate a task. So here I accept the hot patch to activate even after reboot. So then the task start running, and we can see some detail in the task. So after the task is done, you can see the log of the task. Basically, it's a DNF log. And if you regret to, here I just show the CV has been fixed, right? And we can also see the hot patch status by our hot patch plugin. And if you feel regret to fix this CV, you can also generate a rollback task. And after rollback, it will change to the previous state. So here, when we list the CV, list the hot patch again, it is gone. Yeah. That's it, and feel free to scan the QR code. Thank you, guys.